Example 3, rewrite the radical, the square root of a negative 32, using the imaginary unit I. So let's write the expression, the square root of a negative 32. That would be equivalent to the square root of 32 multiplied by the square root of a negative 1. Square root of 32 is equal to the square root of 2 multiplied by the square root of 16 multiplied by the square root of a negative 1. So we have square root of 2 multiplied by 4 multiplied by I, substituting an I in there for the square root of a negative 1. However, to write this in simplified form, we need to write it as our whole number multiplied by I multiplied by the radical. So in simplified terms, the square root of a negative 32 using an imaginary unit would be 4I square root of 2. Example 4. Simplify I to the 57th power. Before we begin this, let's take a look at I. I is equal to the square root of a negative 1. Therefore, I squared would be equal to the square root of a negative 1 multiplied by the square root of a negative 1, which is equivalent to the square root of a negative 1 squared, which is equivalent to a negative 1. I cubed is I squared multiplied by I to the first, which is equivalent to a negative 1 multiplied by a square root of a negative 1. So it's equal to the negative square root of a negative 1. I to the fourth is equivalent to I squared multiplied by I squared, which is equivalent to a negative 1 multiplied by a negative 1, which is a positive 1. Now I to the fifth is going to be I to the fourth multiplied by I to the first, which is equivalent to 1 multiplied by I to the first, which is a square root of a negative 1. So the answer is square root of a negative 1. I to the sixth is I to the fourth times I squared. So we can substitute once again 1 for I to the fourth, and it's multiplied by I squared, which is 1 times a negative 1, which is equal to negative 1. I to the seventh is I to the fourth multiplied by I cubed. So it's 1 multiplied by I cubed. So I to the seventh is really equal to I cubed. And I cubed was equal to the square root of a negative 1. I to the eighth would be equivalent to I to the fourth multiplied by I to the fourth. So it would be equivalent to the same thing as 1 multiplied by I to the fourth. I to the ninth is I to the fourth multiplied by I to the fourth multiplied by I. So I to the ninth is just equal to I, which is a square root of a negative 1. So we just keep on repeating ourselves. Let's go ahead and put it on the left-hand side of this. So I is equal to the square root of a negative 1. I squared is equal to a negative 1. I cubed is equal to the negative square root of a negative 1. I to the fourth is equal to 1. And then we just repeat our pattern here. I to the fifth is the square root of negative 1. I to the sixth is a negative 1. And I to the seventh is negative square root of a negative 1. And I to the eighth is a positive 1. So when we simplify I to the 57th, we can analyze that as I to the 56th multiplied by I to the first, because I to the 56th is a multiple of I to the fourth, and I to the fourth was merely 1. In other words, I to the 56th is equivalent to I to the fourth raised to the 14th power, and then multiplied by I to the first. I to the fourth, let's go ahead and substitute 1 in there. So we have 1 to the 14th power multiplied by I to the first. So I to the 57th is equal to I to the first which is equivalent to the square root of a -1. Example 5. Impedance Z is the measure of a circuit's opposition to the flow of current. Complex numbers are used to represent the impedance of a circuit. The resistance R is a real part of the impedance, and the reactance X is a coefficient of the imaginary unit I. So impedance is R plus Xi, where R and X are both measured in ohms. A certain circuit has a resistance of 18 ohms and a reactance of 2 ohms. Use a complex number to represent the circuit's impedance. Let's begin by writing down the equation. So impedance is represented by the variable Z. And Z is going to be equal to the resistance R plus the reactance X, which is the imaginary part of the unit I. Given in the problem was the fact that the resistance R is equal to 18 ohms and the reactance X is equal to 2 ohms. So let's substitute that into our equation. So we have impedance is going to be equal to 18 plus 2i, where 18 is the real part and the 2i is the imaginary part.